Okay. What happened to my slide? So most of this is about radiation hazards and exposure evaluation, and then a little bit on uh, multiple transmitters if you have an indoor antenna. Only like one question on those. So the FCC, I'm not sure exactly when, uh, and they actually got it from the IEEE. If you remember the chart, which is coming up later, which shows the exposure versus frequency. And they set that as the uh, maximum permissible exposure limits for a controlled environment. It also has, as a dashed line, if you look at the chart, uncontrolled, which means your neighbor, people that don't know they're being radiated. So you have to give them, I forgot now if it's a half or a tenth, but a lot less exposure. And one of the other things that they've changed that came out in this latest question pool back in last July was also adding in electromagnetic exposure. And the main area is basically VHF, 30 to 300 megahertz. It's where your body is most susceptible in that frequency range to essentially heating, you know, your soft body parts, like the difference between, cooking an egg in a microwave versus a steak. The egg goes pretty quick. So do your eyeballs and stuff with a lot of water. And basically it's heating. There's also a thing called the specific absorption rate, or SAR, which is a measure of how fast the energy is absorbed. And of course, the soft tissue absorbs it faster. And I think it's just because of the water. So what is one way RF energy can affect human body tissue? Which was what? Yeah. What does SAR measure? Uh, let's see. Basically, the way they determine your exposure is to look at the power density, the frequency, and the duty cycle. So there's online calculators that you can use to figure out what the exposure limits are. It tells you, how far away you have to be at the maximum level. And you have to input the power density, and it also includes the type of antenna, or whether it's a directional or omnidirectional antenna. And obviously the duty cycle. The lower the duty cycle, the more exposure you can have. And then the frequency is whether you're in that 30 to 300 range. As you go up in frequency, you can tolerate more until you get up into the microwaves, and stand in front of one of those radars is probably not a good thing.
No.
There's the classic chart. This is the updated one, which also has one of those lines has to do with the magnetic, but there's no real details about it. Main thing to remember is in the 30 to 300 range, we're 1 milliwatt per square centimeter. It's the maximum power level that you can do for any period of time.
Measure
The only way to measure it is with a calibrated field strength meter. So and there's a thing coming up. There's 3 ways they allow you to do it. Either go around with a field strength meter, do computer modeling, or do one of the online calculators like the one ARL has. And any of those qualify for your FCC. And that's something you're supposed to keep updated anytime you make a change. And it's one of the few things that you have to have in your station if the FCC guy comes to visit. Probably not going to happen, but if he did, that's one of the things they look at.
Do you have that at your station?
I haven't updated mine.
Yeah.
But since I don't have an antenna up, it doesn't matter. But you even need to do it for handy talkies. I did it for handy talkie and assumed 50% duty cycle, and you got to keep that 10 inches away.
If I all place at the microphone.
Yeah.
It's exactly.
Yep.
So you need to keep your duty cycle down. Or go to 70 centimeters.
Yeah, 2 meters is really bad.
Any-
You use an external antenna.
Well, you can do that, yeah. Like I mentioned, the dash line on there is the uncontrolled level, which is 0.2 milliwatts per square centimeter. So when you direct your beam at your neighbor's house, you have to make sure that he or she is not getting more than 0.2 milliwatts per square centimeter.
Can you explain that chart just a little bit? What, I don't know the frequencies on the,
Right.
on the x-axis, what absorption power on the y-axis?
Is milliwatts per square centimeter.
So I would think that it would be worse the higher up you go on the axis.
No. It's showing the highest level your body can tolerate.
Oh.
So down here at low frequencies, you can do 100 milliwatts. You can do 100 milliwatts per square centimeter there at the HF, MF bands. And then when you get up, you can't tolerate as much on the UHF and microwave, but still a lot, 10 times what you do at VHF. The key is 30 to 300.
That's why.
Yeah.
That's why. Yeah. That's do like the wavelength and like this geometry of the body and stuff. Yeah, that's why the VHF handheld lighter is supposed to be really bad.
Yeah.
Then when I worked for the Air Force, that chart actually had that in the 80s.
Yeah, I believe the IEEE started that chart.
Yeah. We usually had to do calculations for radar for the tennis. Kilowatts. The duty cycle lower.
Over what range of frequencies are the FCC human body RF exposure limits most restrictive?
Sure.
Oh.
And just in case the question happens to show 2 lines at that 30 to 300, be sure you look at one line, kilohertz or megahertz.
Yes. Oh, yeah, that's true. Yeah.
Which of the following is used to determine RF exposure from a transmitted signal? All of the above. What's the effect of modulation duty cycle on RF exposure? Read carefully. Alpha. What does time averaging mean when evaluating RF radiation exposure? That was a line on the previous chart. I didn't mention it.
I think it's good.
Yeah. Oh, it's not 24 hours.
You know, they never defined the period.
Yeah, exactly, it's kind of vague. As those answers are.
Over a certain period. But, you know, a minute or an hour or,
Until you're done.
yeah,
Keep cooking.
time to rotate.
Yeah.
They used to have an exemption. Now the only exemption is under 1 milliwatt.
Pico balloon.
Hmm?
Pico balloon.
Yeah.
No, not even a pico balloon. I'm not sure what would qualify for an exemption.
So we'll worry about this.
Yeah.
But the basic thing is now you're supposed to do it. You're supposed to keep it updated, and anytime you make a change, essentially that would affect your power density, different antenna placement, different transmitter, you're supposed to redo the calculations. Or if you happen to have a field strength meter, you know, walk around and do it. But I don't know anybody that does that. I think it's kind of an expensive instrument.
It's probably or maybe that. And then you have to certify the calibration of it.
Right.
Well, the thing is that you gotta keep your transmitter keyed up with some kind of signal on it.
Now, they actually do it that way at the Space Center. The health physics guy has got that whole set of stuff and goes around and does his measurements. So that's why.
He can afford it, but we're paying.
Yeah. Okay, so there's no exemptions for frequency either. The only real exemption is handy talkies before May 3rd, 2021.
They're the same.
They're exempt. So you got an old Baofeng, you're okay.
Well, why
That's
is
not that old, actually.
Why is that? Because they were more
Bad.
sloppily built,
I know. A lot of spurious harmonics.
big time.
Like I said, they wanna tell you, you gotta jump it.
Well, I'm wondering if they did that because there wasn't rules in place at that time to.
Probably. They decided we got to do something.
Yeah.
Yeah, but then you have to throw away your equipment. So people check it.
What must you do if your station fails to meet the FCC RF exposure exemption criteria? Which means anything but that old handy talkie. Alpha. When must an RF exposure evaluation be performed on an amateur station operating on 80 meters?
You don't have to go any further.
Which of the following types of equipment are exempt from RF exposure evaluations? Again, you're supposed to do the routine evaluations. And like I mentioned, there, you know, you can do the 3 different ways. The easiest is to find one of the online calculators. The ARL has one. I assume there's others. I've only used that one. It's pretty easy. You just fill in 4 or 5 things and press calculate, and it tells you what the distance is. What stations are subject to the FCC rules on RF exposure?
know on board.
Which of the following steps must an amateur operator take to ensure compliance with RF safety regulations?
Sure.
How can you determine your station complies with the FCC RF exposure regulations? All the above. Which type of instrument can be used to accurately measure an RF field strength? Yeah, you can get these little cheap field strength meters, which gives you, it moves the needle.
Yeah. That would be good for maybe relative.
Yeah, it's stronger here than it is there, but you have no idea whether it's
Whether it's within any
Right.
limits.
It's kind of redundant. If you're using a directional antenna, and that's one of the factors you put in is the type of antenna, what the gain is. So you got to make sure if you're pointing it at your neighbor, you're not exceeding the uncontrolled. What must you do if an evaluation of your station shows that the RF energy radiated by your station exceeds permissible limits for possible human absorption?
Yeah, good luck with that. But
That's why I really you guys a little more than.
They just say do something.
Yeah.
It's like a lot of things, as long as you, like politicians, do something, doesn't matter good or bad, do something. Okay, and this is more about the neighbors. You're supposed to make sure you don't cook them. What is one thing that can be done if evaluation shows a neighbor might receive more than the allowable limit of RF exposure from the main lobe of a directional antenna? How do you know when they're present? When evaluating RF exposure levels from your station at a neighbor's home, what must you do?
It's a tricky one because I remember word.
yeah, I think it's probably the uncontrolled engineer.
Because it's not controlled.
Yeah, it has to be one of those two.
Certainly being control your neighbors.
Well, I think they use those terms because you can do your control, you can do something about it. You can turn it off, move the antenna, whatever. They don't know they're being radiated, so.
Then you're accepting the risk, I think. Yeah, I'm just joking about. If you, I had something.
My neighbors have an old organ that I key up on certain frequencies, my voice comes out on them. So they have one on the air.
That's usually the problem, it's interference.
It's like an it's an old Wurlitzer organ that's, I don't know, but
Tubes or something.
And of course, at UHF and microwave, you can get much higher gains because of the relative size of the antenna versus the wavelength. So it can be more of a problem.
Yeah, actually, when we did the radar, it was more of the Fortran program. It was the optics of the antenna, so to speak, because of the dish, right? And that's how you calculate. You put all the numbers in, like we said, and it spit out how far you're gonna be.
Right. What hazard is created by operating at microwave frequencies? For the magnetic stuff, all it really says is your body reacts to both of them, but differently. And then you can have ground reflections, which kind of mess up the whole thing, and you don't know necessarily, it becomes more of an uncontrolled environment. whether you're getting more of the E field or the H field. And of course, they could peak at different locations. So it's kind of a mess, and they don't really go into the magnetic stuff any more than this. Basically, remember those three conditions.
They say at different locations, but are they saying different locations on the body or different locations?
In the
on
area,
ground?
it's like moving around. You know, it's like multipath and stuff like that, because you move a little bit and it's a different radiation pattern.
Oh. That could be like your antenna's in the middle of your backyard all around it. That's how I interpreted this. I don't know how you would measure it, but.
No. And like I said, they don't go into any more detail than these things. You just
Yeah.
have to be aware that it's a little bit indeterminate. So,
Your antenna generates a magnetic field as well as emitting
yes,
electromagnetic.
you can't undo them. There's always an E field and an H field, because one creates the other. As the changing magnetic field, it creates E field, and the changing E field creates the magnetic field. Why are there separate electric E and magnetic H MPE limits at frequencies below 300 megahertz? And that was that other line over there, which they didn't really say much about.
No. Oh,
Where'd you go? You can have a situation where there's multiple transmitters in an area, like broadcast court or places where you've got a lot of people with different antennas on the same tower or in the same area. So they come up with this thing on how you evaluate the site, and they come up with this thing. If you're contributing 5% or more of the radiation in that area, then you're also responsible for making sure that you're not exceeding the permissible limits. It's kind of a confusing thing, and I don't know how you work it out, but it's a new rule. So when evaluating a site with multiple transmitters operating at the same time, the operators and licensees of which transmitters are responsible for mitigating overexposure situations. And if you have an indoor antenna, not always a good thing, especially a magnetic loop sitting on your desk. Probably don't even have to run that much. Obviously, you can be closer to the antenna if it's indoors than outdoors, possibly. So it's easier to exceed the limits. What precautions should you take if you install an indoor transmitting antenna? I like alpha.
We're close to these ones.
Yeah. Reduce that feed line loss.
Got a sheet on the antenna for it.
So we talk about what SAR meant, what the effects on the body of, heating, basically heating your body tissue, because it's not ionizing radiation. It's non-ionizing, so all it can do is heat. But enough heat will cook you. It's most restrictive in the 30 to 300 range, basically VHF. You have to take into account duty cycle frequency, power density, which part of that is the antenna gain. Time averaging just means the total exposure averaged over a certain period of time, which they do not define that period of time. Yes.
Do you think that they determine, or they specify VHF as 30 to 300 megahertz. Did they have this in mind when they?
No.
said that's gonna be
No.
VHF?
because those ranges have been, they just decided, HF is 3 to 30, VHF is 30 to 300, UHF is 300 to 3,000, and they go that range when they divided up the spectrum and called it.
Okay. So it just happens to be that,
It just turns out that in that range, and I don't, they draw the curve like it's just flat at 30 to 300. I doubt that it's exactly like that. It's nature doesn't do those kind of things. There's probably some frequency, and it may be dependent on the person where you're most susceptible.
I meant to go back and find this, but when I was taking either my technician or general test, they mentioned specifically 50 megahertz as the frequency that is most effective on the human body.
Well, in the amateur band, that would be true. Like,
Right.
pretty much. I mean, it's going to be 50 or 144 are the only two in that range.
Well, what do you think about 144 to 50? Has always stuck in my mind. I think, well, 6 meters is hazardous to the human body.
More hazardous.
No hazard.
Yeah. Don't play at 6 meter. Whoops. Whoops. You always have to do the exposure evaluation. The only thing exempt is the 2021 handhelds, or stations where you're below a milliwatt over time. Now, Pico balloon might qualify because it is what, every 30 seconds it broadcasts?
Yeah, it's not continuous.
So it might actually be below a milliwatt average.
Mine's at 50,000 feet, so I think we're good at it.
Well-
The distance will help with that.
Right.
But
You just can't fly up close to it.
Yeah,
You're up at 50?
that's where it's been since.
Really?
I guess around, it's been a long time.
45.5 is the highest one seen lately.
Yeah.
It's just under 50, it's over western China now.
Uh-oh.
It was hanging out over Russia for a long time.
Yeah.
It's where the wind speed are really low, it's in the North Pole. And so rather than saying that's probably why it survives so long, because everybody else gets their thunderstorm and that's just that's.
Well, that's East China is where mine died.
Oh, okay.
I ran into a typhoon called Kraken.
Yeah, mine was, we launched it the day before Thanksgiving. And so it was in the winter, and yeah, it was going over like the Middle East at the time, over that part of China, but it was January.
When you were over the stands, did you see a lot of weird points on the plot? Because mine, whenever it got over, China and the
Yeah,
Pakistan and stuff, you couldn't really tell where it was because you get all these weird
there's a
GPS.
They're screwing around with GPS.
You do see that, yeah, I saw horrible Russia. So now when it gets near the western of Korea, South Korea and Japan starts picking up like crazy, so.
How many revolutions are you?
I've stopped counting at some point. No.
I almost made 5. If I'd have made it across the Pacific, it'd have been 5.
It's been so many, I stopped counting.
Somebody is approaching the 13th.
I think it's him.
It's been around there even more than that. Really? And it was like, I was already like 9 or 10, like in February, so.
I was thinking it was Bob. Maybe before the city. Maybe not.
I don't know. He's been posting about them. I don't know if it's his.
Well, he was stuck up in the Arctic Circle for a long time.
Yeah,
That's
I
what
got
happened, Yeah.
I got up there once for a while. In fact, I got 50 miles from the North Pole one time.
Wow.
And that little station up there, got the name of it now, was picking it up. And
There's not much activity in the southern hemisphere.
no,
A lot of people don't live in something.
Well, yeah,
It's in Poland.
well,
they
I,
don't usually go down
well,
that far south.
I guess one of the.
that's because of the wind patterns. I don't think it could make it across the equator.
Intertropical something zone. That's all thunderstorms out there.
And usually they're following the jet stream. If you look at that windy or the other vertisky or whatever, I mean, it's pretty much west to east around and with vortexes and
So we have to go south of the equator to launch
yeah.
to get activity.
And
in
you'd be
there.
down there and then you get down to the Antarctic and
Yeah, cause, yeah, I guess there was a personal favorite, right, he said that, Lisa, he said her balloon actually somehow shot across the equator, didn't get down to Antarctica, then disappeared sometime.
Wow.
It's not a lot of stations.
Disappeared and reappeared and then disappeared.
Yeah.
okay, we better get back.
Yeah, yeah, you can get really, nerded out.
How you calculate is per the FCC bulletin, so you can do the online thing or computer modeling, which that is basically based on, or actually go out and measure it.
Stick with your mouth.
It's like somebody's waiting to be admitted and waiting.
Oh, Chuck,
Is that, oh, that's John.
We just
Yeah.
let's get in,
I didn't know his name was Lucas.
what's that his handle?
It's a W4 TZO or something.
something like that. So you're supposed to take action to correct the situation if you're exceeding the limits, especially if it's your neighbor. UHF, because of the high gain antennas, can be a bigger problem. And also you have to now worry about the magnetic field. Although they don't say a lot of details, and I don't remember on that chart where they drew the magnetic line. But it seemed like it was pretty high levels over there below 30 megahertz. They didn't really define it in the 30 to 300 range, what the magnetic field density would be. At least I didn't see it. If you got multiple transmitters, then everybody that's more than 5% has to get involved in mitigating the situation. Not sure how you figure out whose radiation pattern is whose.
Yeah, just that they derive from E field, I went all the way back to that term. Yeah, cool.
You'd have to have a frequency selected.
Yeah, I mean, everybody was, well, it's unlikely, but if everybody was in the 2-meter band,
It's a lot.
Very difficult to identify the power of each.
right?